Okay, we might have one attendee.
Yeah.
I will just checking if you can hear and see us. So I believe you should be able to put something in chat. Oh, here is another person. Harry. Yeah, I could probably enable some. What I'm going to do, I'm going to enable both of you so I'm able to talk. But if you keep yourself muted, maybe for time being, and then at some point for the Q&As, we're going to enable your mic. Okay, I'm just going to leave it for a few more minutes if anybody else is joining. Okay, we have another person, Tyler. Okay, so first of all, welcome to you all. It's great to have you here. Welcome to the open day for MSc in Nanotechnology program. So just to double check, can you still hear and see me? Or more importantly, can you see my presentation? Maybe Nafta, if you can just confirm I don't see chat. Okay, yeah.
Adnan, yes, I can see you and I can hear you and I can see your presentation.
Excellent, brilliant. Okay, so welcome to you all. My name is Adnan Mehonic, and I'm a lecturer in nanoelectronics here at the Department of Electronic and Electrical Engineering. We also have Nafta, who is kindly monitoring the chat. So if you have any comments, you can put it in chat now, but please be aware that after this very brief presentation, you will have a chance to ask the questions and we can discuss any issues or concerns or questions you might have. So this is our MSc Nanotechnology program for the year 2021-22. So sorry, 22-23. So let's just start with a big picture. Why is it that we're doing nanotechnology at all? And how it all have started. Of course, you know that today nanotechnologies apply for a very wide range of applications. It's actually quite hard to think about the technology which has not been impacted by nanotechnology in some way. But it is fun to remember a bit of the history, how it all kind of started. So you maybe are aware of this quote that came from a famous physicist, Richard Feynman, who says there is a plenty of room at the bottom. And I believe this statement was made back in 1959. at the American Physical Society meeting. So what Feynman was talking about was that there is a great power to be unlocked if we are capable to manipulate objects at a nanoscale. So basically, if we are able to build the systems from bottom up and really start to work with the nanoscale objects, we can then define the properties of the systems we are interested in. And this has become true many years ago, actually. And today we can see how nanotechnology and nanotechnology techniques are applied to produce anything from our model computers to the applications in medicine, pharmacy, and so on. We're going to see a bit more about that later. But what I also want to do is just to give you the some intuition and sense how indeed a nanoscale is, how small it is. So here is a bit of the mental exercise. So let's say you start with imagining the planet Earth, right? In the size, we might have some intuition how large the planet Earth is. And then if we scale down the planet Earth by 10 million times, we get to the size of the average football ball, right? Which is 0.2 meters or something like that. Now, how about if we do the same process again, but not only 10 million times, but actually 100 times more. So to get to the 1 billion scaling, we get to the object, and this is a C60 molecule that is roughly speaking around 1 nanometer, a bit less than that. So indeed, you can see how remarkably small the scale of nanometer really is. Then we need to think about the applications. I already mentioned some, but let's just go through some of them anyway. So our microelectronics, of course, which is this term that's used for the development and technologies related to our modern IT devices, really became nanoelectronics maybe 10 years ago. The basic fundamental building blocks that we use are transistors, and each transistors these days are in a single-digit nanometer scale. So this is quite remarkable that we are already using nanoelectronics, not really microelectronics. Then we can see how nanotechnology could also be applied to other applications, for example, textile industry. I said that by manipulation of nanoscale objects, we are able to define the properties of the certain physical systems. So for example, you can have a textile that is hydrophobic, meaning it repels water, and that's quite useful, especially in cities like London, get a lot of rain. So if you have a hydrophobic jacket, that would be quite handy. Then, of course, we can see how nanotechnology could be applied in food to extend the shelf life, but also to have the how the certain food can be taken. So, for example, nanospray supplements and so on. And more recently, and maybe even more relevant for the current situation, is how nanotechnology is applied in medicine and pharmacy. So it is indeed quite a broad subject. So when you think about the nanotechnology, maybe that naive view would be that people would immediately think about the nanorobots. But actually, nanotechnology is much broader than that. And the real applications are maybe those that you are not even aware of, or we are not aware of. So how about the MSc in Nanotechnology program at UCL? So what do we offer? And we believe this is a quite a unique, excellent program that really gives you a lot of these fundamental tools that you can later use either if you choose to do, for example, PhD to stay in academia, or you indeed go to the industry. So we start with the fundamentals. Here is one of the compulsory modules in the term 1 that we have, that's a physical sciences for nanotechnology. So we start by teaching physics that is relevant for nanotechnology and related technologies. So we start with the understanding of the quantum mechanics, because once we are down at the nanoscale, the rules of quantum mechanics become really important. But then we also discuss solid-state physics. You also get to see how these technologies are made and also how you can manipulate these nanoscale objects for yourself. So we have experimental-based module called Experimental Techniques for Nanotechnology. And in this module, you will get the chance actually to go to our nanotechnology laboratory, where you can work with the STM scanning tunneling microscopes and atomic force microscopes, and then to do this yourself. So it's not just the theory, you also get some hands-on experience. You also get to learn about how our modern chips are actually fabricated. It is good to understand how the single chip is, well, single transistor is fabricated, but if you take into account that the modern microelectronic chips now consist of billions of transistors, we really need to think about how is this done at a scale and efficiently. So this is another module that's going to help you to do that. Then we have the module that links these fundamental physical processes that we can use to define useful functionalities. So this could be used for the functionalities of the technologies and the devices we currently use, such as transistors, but also for technologies beyond that. Then another module talks about how about if we use photons rather than electrons for information processing. You know, currently all your computers are based on electronics, but we could also think about photons and trying to do some manipulation or calculations or computations with photons rather than electrons. That's the field of photonics. So we have a dedicated module for that. Then very importantly, it's not only about the that you're going to learn about the technologies and physics and engineering, but you also get to learn about what is the wider impact of these technologies. So we have a module called Nanotechnology in Society. You're going to learn a bit more how do you impact policy, and what is the important policies that you need to be aware of, more generally speaking, the impact of these technologies to the society. So not just to think about, okay, this happens in the lab, if this becomes reality, you really are responsible in a certain way to think, okay, what is going to be impact for this, and are we going good in the world by developing certain technology? And finally, this is a very, very important and a critical part of the program, which is typically worth 1/3 of the whole degree. It's the research project. This research project happens in the from the second term, so in term 2 and 3, and you get to choose from the list of many different projects, the project you want to do. In these projects, you get to do both some maybe theoretical analysis, data analysis, but also the big part of that is to do something experimentally. So some of these projects could be based at London Centre of Nanotechnology, where you might get to see or to work in the clean rooms. And we have a very good state-of-the-art clean room indeed at LCN. And then on top of that, you also have quite a broad range of the optional modules that you can choose from. So here are some of the examples. You have quantum technologies or related to quantum technologies. You have more about condensed matter physics. You also have the modules related to molecular biophysics and physics. Also entrepreneurship for you who are thinking maybe more about starting up your own companies. So this is quite useful. So with that, as I said, this is a very short presentation of what we have. Of course, many more details you might be able to find on the website, but it says in specifically the syllabus of these all different modules, and also how the whole program is structured in terms of the terms and what do you do. But if you still have some questions, please use either one of these two emails, so either MSc Inquiries, or you can also email me, because I'm a program director for MSc Nano. And with that, I'm very happy to see if you have any questions, and I think it might be a bit more meaningful if I answer to you what you're interested in. Okay, so how should we do this? I don't think that we have any questions at the moment. But
since there's so few of us, if people wanted to open up their audio to ask a question, Adnan, are you okay with that?
Yeah, absolutely. I mean,
Sure.
That's much more useful if you can just talk. Let me know if you can unmute yourself.
Okay, yeah.
Great. I will.
Oh, sorry. I'm actually still on my lunch break. Someone's calling me. I'm just going to message them quickly and let them know that I'm like in this meeting, and then
Yeah, sure, no worries. I mean, if you need to do something, but yeah, if you have a question, please go on.
Oh yeah, no, sorry, I do have a question. I was wondering if you had any examples of the projects that people will take, because I can't find a list online on the website. I know that like nanotech is like very cross-disciplinary, so I was wondering like what areas people generally go into, sort of thing.
Yeah, exactly. So the reason why you don't see these projects available online is because they change every year.
Yeah.
And the reason why they change is this project should be really the bridge if you're thinking about doing a PhD.
Yeah.
So not only to maybe learn about how this independent piece of research is done, some of these projects actually do end up getting published, but also to maybe get to know other academics. So if you're thinking maybe about staying at UCL, but more specifically to the point, what kind of the projects we do offer. So most of them is going to be related to nanotechnology, but more specifically to nanomaterials. So you will have the people who are working on nanoelectronics. So developing, for example, electronics based on 2D materials. Also the people who are working on development of novel technologies, so something called memoristic technologies or neomorphic technologies. So this is all kind of related to doing, I guess, two parts of the work. So one would be the experimental work. We have a nanotechnology lab at our engineering building, and you get the access to many different types of the microscopes. But you also get to maybe do a bit of the spectrometry and also to do the electrical characterization. So it's typically that. It's kind of, you get a device or piece of material that you need to somehow characterize, and then you see, are those properties that you managed to get, are there, how do they compare to the technologies that are already available? So that's a lot of stuff that we do. There is maybe some other projects based in the physics department, which could be a bit more theoretical, and also related to maybe biophysics. So we had those in the past as well. But I would say the majority is kind of based on nanomaterials, nanoelectronics. Some of them are actually based on producing smart windows. So maybe if you want to put, what is a smart windows is a thing that could adapt, for example, depending what are the conditions to transmit or reflect heat or light, right? So we have quite a broad range of these projects. You typically get those at the end of the first term, so just before the new year, and you get a couple of weeks to consider them, to talk with different academics before you make your selection.
Okay, cool. Thanks. Yeah. Yeah, no, my undergraduate was in like natural sciences. So I specialized in molecular cell biology, but also in physics in third year. So I've got like interest in more like, I guess, biophysics area is interesting to me. But yeah, so that's good. Thanks. I don't know, I can't see who else is in this call, so I don't know if there's actually anyone else here to ask questions as well.
Yeah, so there's a few more people. Maybe I could just say one thing about you're coming from the different backgrounds. So the one nice thing about this project, we do have sort of introductory modules that sort of try to introduce a different concept, not relying too heavily on your background. And these are compulsory modules. So for example, physics for nanotechnology would introduce the stuff like quantum mechanics, if you haven't been listening that in one of your modules. But also for people who are not from the engineering side of things, they would introduce, starting from solid state physics, what is a transistor, how it's used, and so on. One note that I would like to make is that you need to be only careful about your optional modules. So these optional modules, which indeed could be biophysics, do assume that you actually have maybe a slightly more stronger background in some of those, but that's then you should make the selection of your optional modules depending what is your particular background.
Okay, thanks. I guess I'll just ask one quick question, which is about like the funding. I noticed that the price of the course obviously is quite expensive. One of the issues for me personally will be trying to save to do it. I was wondering if I applied and got accepted, but then the finances didn't meet end sort of thing, I had to like save longer. Is there any process with UCL with regards to deferring accepted agreement, like accepted offers, or how does that work sort of thing? And After that, I'll just dash off.
Yeah. That's obviously very important, a relevant question. So I don't have a very good visibility because these kind of things are needed to be managed centrally and also need to be the same across all the programs. Obviously, it will depend if you're a home student or overseas student, so the rates are different. I could try to make inquiry about specifically about this, but what I would also suggest is if you email maybe admission office at UCL just to ask about this question, because it's need to be the same across all the programs at UCL, and we have loads, so they will be able to tell you what can be done. Also, we have this system for applying is Portico, that I believe you are using Portico. Might be using something else, but gets us through this system. Well, you should have actually some emails that you can drop an email. They will be able to actually give you a much more comprehensive answer with all suggestions. And Nafta is posting something in as well. So yeah, admission inquiries. Thanks, Nafta.
Okay, great, thank you.
Hi, I've put a couple of questions in chat if you want to look at them.
Oh, sure. Okay.
Thank you.
Let me see if I could get to chat. So I can see Nafta's. Okay, Henry. Yes, indeed. So it seems so that the main program is focused on the attributes of other things. Could you expand more on the biology and medical side? Yeah. I think that's a fair comment. Although at least on these compulsory modules, but you can also choose at least 2 modules which are more related to biological or medical side of things. So to say this is, it's not, the program is not associated, I guess, with the biological department. It is mostly associated between EEE mostly. This is where it's the core, and also physics. But we have the lecturers and professors from the other departments as well. So what I would say, probably the biology and medical side of things is not the, in terms of the compulsory modules, it's not the strong component, but then you can always augment that with the optional modules and also take a research project, which is 1/3 of the whole program, which could be based on these kind of topics. Okay, so there is another one coming from the computer science background. Do you get many applicants from this course applying to nanotech, and do you think it would be feasible for me to do so? Yeah, I mean, we do look at your background, obviously, and then in particular, what kind of the modules you had previously. So if you have some background in physics, for example, if you know, and maths, obviously you would. Engineering, as I said, it's kind of introduced at a level that you would be able to follow. Of course, because one sort of benefit, but also maybe a bit of the challenge for the students is when you're coming from all of these different backgrounds, from these traditional disciplines, and then you're listening in nanotechnology, which is sort of broad, you would need to sort of pay attention to some bits that you haven't had the chance to listen before. So for example, for somebody coming from computer science background, maybe you will need to spend more time thinking about the quantum mechanics or solid state physics. But then again, I could give you a personal opinion. I'm coming from the engineering background and I did this degree many years ago. So for me, it was the first time was actually listening some aspects of quantum mechanics. And I managed to do it quite well, but I had to sort of do some things on my own as well. So kind of pay a bit more attention to it.
Yes, it's kind of the extra work in to achieve the course.
Yeah, exactly. Okay. So it's and other academics are very open, very accessible. So it's always a good idea to just say, okay, this is my background. What do you think I should do if I'm sort of haven't heard this stuff, or I'm hearing something for the first time, that they would be able to help.
Thank you.
Okay, so do we have any other questions? So one general suggestion from me would be to try to make your applications as soon as possible, because we're basically working on the kind of, not really, but these applications, because they're open for many months, do get processed in stages. So then maybe sometimes if you make your application early on, it might increase your chances. Okay, any other questions? Right, okay, so this is the question of all questions, and after please come in if you know more, obviously related to COVID. So we had quite a challenge in the last 2 years, especially in terms of the MSc program. So currently the people who are in London, in the country, we are assuming all the material is pretty much in person. So you would be coming to the campus, you would have these or at least the big part of the lectures being given in person, and also the experimental part of your module is going to be, of course, fully in person. We have allowed last year, not so much this year, for some people to do it remotely, but this is not really advisable, and we sort of need to make some provisions. So for example, this year in our department, we did allow the students to take some modules remotely, but the physics didn't. So then for people who are looking to take these optional modules coming from physics, it was a big issue because they couldn't really take it if they are not in the country. So I would say it would be sensible and reasonable just to count that the program would run in person. Thanks, Nafta. So Nafta also put a link in chat where you can sort of follow this, I guess, week per week.
I just wanted to quickly add here, actually, if you don't mind, Adnan.
Of course.
There are a number of precautions also that UCL are taking to ensure that the population that has congregated at UCL within the campuses and the buildings, things like we are requesting for students and staff to take regular lateral flow tests. There are sites available at UCL and around UCL for that to happen. So there are a lot of provisions in place to ensure that in order for teaching to happen in person, that safety measures are taken. There are a lot of kind of sanitation areas around. We're deep cleaning regularly. So just for you to know that in the background, there are a lot of things going to ensure that classes can happen face to face. So and you've seen that link in the chat. Do keep an eye on that link. It's pretty much updated on a daily basis. So I hope that helps.
Thanks, Nafta. Okay, so any other questions? Okay, I guess if not, that would be all. So I'm really looking forward to see you and see your applications, I should say, and I'm hoping you are going to apply. This is really, I could tell you from my personal experience, because I took these modules and then went on to do PhD, and I'm now academic at UCL. This program was maybe the most critical part during my education process, and it's really excellent in terms of what it offers, and you sort of learn about different things in different ways, not just one particular subject. So if you have any further questions, you can email either the emails that I show in my presentation. So you should always be able to email me. There is also MSc inquiries, and I'm sure you can also send an email, as Nafta kindly pointed out in chat, to Nafta. Okay, so that's all. Have a nice rest of your day. I guess you're all in the UK, or in the same time zone. So yeah, that's great. See you all.
Thank you all.